So I would love to talk about the Triassic world. The Triassic world, 250 million years ago to about 200 million years ago. And for me, this is the most important and interesting and exciting moment in the history of life on Earth. We have the end of the reign of some weird animals that sort of became extinct, and then even weirder animals evolved during the Triassic. But at the same time, there was also the earliest mammals, the earliest crocodiles, the earliest turtles. During the Triassic, the continents were all joined together to form this supercontinent Pangaea. And it was sort of separated into the northern part, Laurasia, and the southern part, Gondwana, by this major ocean, embayment, in essence, in this huge supercontinent. And this ocean was called Tethys, the Sea of Tethys. And living in the Sea of Tethys, there's a variety of weird animals, animals with long necks, animals with hammerhead snouts, and also representatives of some of the earliest members of the turtle family. So we see this sort of striking difference between the modern and the ancient living together, these sort of archaic forms alongside essentially modern-looking animals. And around the world, there's all sorts of sites. So in China, there's some of these sites producing these weird marine reptiles. You can get the same sorts of animals in the alpine regions. And if you come to Britain, you start to see some really interesting areas in the southwestern part of the UK. There's fisher fills with early crocodiles, an animal called a sphenodontian, or a rhynchocephalian. These are related to lizards, but quite distantly related in some ways. And today, rhynchocephalians are just survived by one single species. That's all that's around. An animal called sphenodon living in New Zealand today. But also in the UK, apart from these fisher fills, in Scotland, in the northeastern part, in Militia, the so-called Elgin reptiles, or from the Lossiemouth sandstone, produces some really interesting animals, crocodile-like animals. There's a thing called Staganolepis, which was a plant eater. There's another animal called Hyperodapodon, which was also a plant eater with sort of big barrel-shaped chests. But alongside these animals are things that were related to Sphenodon, the rhynchocephalians. And that is a group which I have studied a lot during the course of my career. And I find it really quite remarkable that these animals all living together, they are buried, or were buried at the time, in sandstones, almost like they were dune fields. And it's quite remarkable that all these different animals which were relying on vegetation, there doesn't seem to be any sign of vegetation. So we think we know a lot about these animals, but there's all sorts of things still to find out about them. And over the last couple of hundred years, people have been studying these things, and we still don't know all there is to know about them. We are refining what we know about them, but it is just so exciting to come back to places like Elgin, re-examine with new techniques how we work on these animals and how we work on these fossils. And the Triassic world is still giving up its secrets slowly. We are beginning to paint a picture of this world, which was actually a greenhouse type of climate. There would be no polar ice caps. Here, thriving in the Triassic world are the building blocks of the modern terrestrial ecosystem. So things like crocodiles, things like early mammals were there alongside the dinosaurs, alongside the earliest turtles, but also alongside these weird animals like the aetosaurs, like the rhynchosaurs. And it really was this absolute wonderful mixing bowl of past weird animals and what we would consider today modern forms. In my hand is a 3D print of one of these rhynchocephalians or sphenodontians, which comes from the Elgin sandstones, or the Lossiemouth sandstones. So here we have the skull of Brachyrhinodon. This, towards me, is the snout, and that is the back end of the skull. And on top, the orbits, the openings at the back of the skull are around these openings would be attached the jaw muscles, and giving it quite a, for its size, a fairly powerful bite. And you can see just in side view how it is squashed flat. So it would have been in life a much taller skull than it is seen here. But it was still very well preserved in the sandstone. It may not have had the bone in there, which is a good thing in some ways, because the cavities are a faithful replica of the bone itself. So it's easy now for us to scan them and then reproduce these 3D models, or 3D casts, to be honest. They're not models. This is a faithful restoration of what the skull was like when it was bone inside the sandstone. Beautiful little animal, and with the lower jaw coming along the bottom side there. So clenched together. And it looks very like the modern day sphenodon living in New Zealand. So much so that the similarities were so striking that people started to talk about these animals as living fossils, because they had this history going back 200 million years ago. And for a lot of people, they apparently didn't seem to have changed too much in that period of time. Now, the term living fossil is something which I find really quite challenging. And I don't think it's a particularly useful term. Many lizards are very similar. They go back to exactly the same time period as this little sphenodontian, this thing called Brachyrhinodon. We don't call lizards living fossils. So why should we call these living fossils? They too come in all sorts of different shapes and sizes from the beginning of the end of the Triassic onwards till today. So through the Jurassic, we have marine forms of rhynchocephalians. We have herbivorous forms with quite large, big, robust skulls, with a dentition capable of feeding on plant material. They are really, or were, really, really varied. So the term living fossil is not a particularly helpful one. Unfortunately, sphenodon, living in New Zealand today, is encumbered with this term, which I would like us to start moving away from, if at all possible. Because this animal is very, very different to sphenodon, and possibly had a very, very different type of behavior. And so I think sphenodon has come a long way, in the same way that different lizards have evolved over that 200 million year period to this diversity of today. Just because there's only one rhynchocephalian left doesn't mean to say it is a living fossil. Working on the Elgin reptiles, particularly the ones from the Lossiemouth sandstones, these Triassic age ones, work will go on. New discoveries are sometimes made, and new technologies come along to help us better understand these weird fossils. And I would expect, with all the people out there in this area studying them and looking in the quarries for new finds, we will be still not having a complete picture of life in the Triassic for the next 30, 40, 50, 100 years. There is still so much more to find out. We have come a long way, but there's still a lot more to learn.